Hello everyone, and welcome back to my videos. And back to my 224 is the Calc 1. And this topic is more comfortable for you guys because I know you guys hate some algebra. So we're going to introduce section 3.1, the basic differentiation rules. So let's get started. Derivative, according to our definition, of a function perhaps f of x can be obtained by a limit so it's like this. And for now, we're getting to some shortcut to find what is f of x. Introduce some like the basic rule, and if and the first rule is like a constant rule. If f(x) equal to a constant, then the derivative is a 0. So we can say that this number 1 is ddx of a constant is a 0. And now, before we introduce more differentiation rules, we're going to introduce what is the notation of the derivatives. There's a many way to represent the derivative of a function, but mainly right now we have ddx is just 1, and it's like dy dx, dx, dy, and f prime of x, or whatever it is. Also, the most four common like notation we use to find the derivatives. And number 3 is the power rule. If g of x has the power of n is not a 0, then g prime of x is number 2 is n x n minus 1. And now we're going to introduce some like operations like the addition, subtraction. So this is like the kind of the most basic rules that we can learn in 3.1. Number 4 is like the constant multiple of. Introduce if a function if perhaps hx is a function is equal to c times f of x, then h prime of x is, we have a constant multiple, but we don't do kind of a product law here because it's not taught in 3.1 yet. So we just pull out a constant. It's like h prime of x is equal to c times f prime of x. I'm not going to introduce like how those are proved because method 24 is calculus class, and they don't need to do how to prove that how those are proven, how they're obtained. So basically, what I'm gonna teach you in this video is how to compute the derivatives. That is the main purpose of this video. And number 5 is the addition for any two functions and derivative is number 4 plus g of x, it is ddx of f of x plus of ddx of g of x. Also, number 6 is like another subtraction. Well, I maybe call them subtraction rules, but it's not, but it's the same thing, just like the difference is the same as subtraction.
Number 5, I think.
Oh my. Making this kind of like stupid mistake.
Minus ddx of kx.
Last one, number 7, I promise this is kind of a last one.
Number 7 is exponential rule. If mx is ex, then the derivative is six. Dx of ex, it is ex itself.
Let's do some examples here.
Example 1. Find the derivative y equals to 3x minus 7ex plus x to the 4th.
So we can also write the notation as
y
prime is also the notation. This is number 5 notation.
just do ddx 3x minus ddx 7ex plus ddx, it is x to the 4th. And we have is like
The notation
just the y prime, it is 3 minus 7ex plus 4x to the cubic.
that is the
Derivative of the function. Try that example here. Example number 2. Find the derivative. If we say f of x, it is 6x to the 6 minus dx plus radical of x minus x to the 10th.
because this is like bit of a harder, but it's not.
So just apply the laws. This is
6x like a -6. Write it like a negative exponent form will be easier.
And then just the plus is ddx is like the x to the 1/2 minus ddx to the x to the 10th. We just so we just have this expression
F prime of x is the derivative notation.
gonna be -36 x to like a -5 or -7.
Oh god.
Full like lots of integrals, but I'm just going to mess it up. I apologize for it. Minus ex plus 1/2 x to the -1/2 minus 10x to the 9. This is the derivative of a function.
Another one.
Example 3. Find the derivatives
So if we
if g of x it is
yes, this function, all you see is a fraction. And you wanted to do the quotient rule. But here's the hint. They're all in terms of x. So you can just rewrite the function into this. And then you can compute the integral. Oh, no, compute the derivative. I'm so sorry that I just made a minus 25 videos. And that's why my brains are full of integrals.
then just to get this is g prime of x. It is this is like a 0, 2x, and a -8 x to the -2.
Okay, to another one.
Example 4.
Compute the slope of a tangent line. Slope of a tangent line.
to the curve hx like 4 x to the cubic minus 10x to the squared plus 5x at x equal to 1.
So in this case, we need h prime of x and h prime of 1. So we just needed to
compute what is h prime of x is. The dx of 4x to the cubic minus the dx is 10x to the square plus the dx of 5x. And what you get is h prime of x. It is 12x to the squared minus 20x
plus 5.
And the slope of a tangent line x is 1 and slope of the tangent line at x equal to 1 is h prime of 1. So h prime of 1, it is 12 is for negative 8 plus by negative 3.
That's it.
Example number 5, do you like another one? Compute slope of the tangent line to k of x equal to 4x minus x to the cubic plus 12x to the squared at the point is 2 with 8 minus 8 is 0 plus 12.
248. That is like the slope of a tangent line at,
And we need to find
k prime of x and k prime of 2.
so k prime of x, it is 4 minus 3x to the squared plus 24x. And so the slope of the tangent line at x equal to 2 is k prime of 2 equal to 4 minus 3, 2 to the square plus 24 times 2 is a 48, 52 minus 12 is 40. Wait, 4 minus 12 is 40, yes.
And now when you introduce more even a concept, it's like harder problem is to find the equation of a tangent line. Yes. Equation of the tangent line to f of x, it is x squared plus 4x to the 5 minus 27x to the cubic at x equal to 2. Okay, so equation of the line, so it's like a linear equation, right? And then we introduce like a different concept. It's like the point slope form. Point slope form. Is y minus y to the 0 equal to m x minus x to the like a 0. This is the point slope form for tangent line. Yep. So we need to find what is f prime of x. Well, just is 2x plus 20x to the 4th plus minus 81 to the squared. Actually, this is just the equation. This is just the derivative. F prime of a 2, it is m actually. It is 4 plus 2 to the 4. This is 220 minus 2 to the 4 is 324 is 0. So if the slope is 0, then we just write it as I to the 2 is 4 times 128, 132. 132 minus 200 is 16. 132 is negative 84. Zero and is x minus 2. Actually, y equals to negative 84 is the slope of a tangent line. That is in case just the y equals to negative 84. And let's do more example. Example number 7. Find the point where the tangent line
2 g of x, it is x squared minus x plus 10x to the cubic is horizontal. So the one possible hint for this video is horizontal tangent line is horizontal tangent line is where the derivative is 0. So in this cases, we need to find just to find what is the g prime of x is. It is 2x minus 1 plus 30x to the squared. So it is basically like 30x to the squared plus 2x minus 1. Use quadratic formula that roots can be like a negative b, negative 2 b squared minus 4 a c over 2a 60. Gonna be like a negative 2. It's gonna be minus square root of 124. Over 60 is equal to negative 2 plus or minus 2 square root of 31 over 60. That's where the function have a horizontal tangent line, just a set equal to like a 0. Okay, let's try over the last example. Find the equation that is perpendicular to the tangent line of y equals to x to the cubic plus 1 at x equal to 3. Okay, so this cases what we have is for 3 and 0.3 3 and a 28. Just to draw like a visual. At 328, does this point on graph? This graph is not going to scale. And I want to say, what is a perpendicular? So if the slope is 3, not yet 3 here. So when you find what is a y prime, it is 3x to the squared. And you want to see it's like this slope of y at y just in the line at x equal to 3 is 18. It is 27, yes. So it's perpendicular. It's the reciprocal of the equation. We wanted to see what is the slope of the light blue line because of y2. So m of y2 it is. So this time we call it y1. So it is going to be negative reciprocal here, y1. So it's going to be negative 1/27. And the formula should be y equals to mx plus b. The y is 28. So it's like 28. It is. I'm gonna be negative 1/27 times 3 plus b. 28. It is gonna be like a negative 1/9 plus b. And b is 253/9. So equation of y2, it is negative 1/27x plus 253/9. Okay, that's all for 3.1. In next section 3.2, we talk about more advanced rule to find the derivative of a function. Thank you guys so much. Have a good day.